Welcome to another episode of AI Talks with Chris and Nita. We have some really interesting material here. It looks at all these different ways AI learns. So yeah, we're going to try and give everyone listening a really clear and concise overview.
Yeah, absolutely. So think of this as like a cheat sheet almost to understanding like the core of what makes AI so powerful and how it's able to do all these amazing things. You know, we're seeing more and more of what AI can do every day, but how does it actually get to that point? How does it work? Well, we're going to be exploring all the main ways that AI systems kind of learn and improve over time.
So if we want to start right at the very beginning, like what even is AI learning?
Okay, so at its most basic, it's basically how AI systems get better at different tasks, right? By like processing data. But it's not like we're giving them step-by-step instructions for everything. Instead, what happens is AI actually learns to like recognize patterns in the data and make decisions based on that, and also predict outcomes.
It's like learning through experience, but it's all happening in code.
Exactly.
So, okay, one of the big ones that we hear about all the time is supervised learning. Can you kind of break down like the main idea behind supervised learning?
Okay, so think of it like this. Imagine you're learning with a textbook. You know how textbooks usually have like questions and answers, right? So in supervised learning, it's kind of like that. The AI learns from what we call labeled data. So it's input that's paired with the correct output. So basically the AI learns to match these inputs to the outputs. And it does that by like minimizing errors.
So we're basically giving it all the answers so it can figure out how to get there, like figure out the pattern.
Exactly. Yeah. And it's really good for a lot of like prediction tasks. You know, some common algorithms we use are like linear regression, decision trees, and neural networks. I'm sure you've heard of neural networks. Those are really popular.
Yeah. So we give it the answers, it figures out the patterns, and then we move on to unsupervised learning, which sounds like the opposite. Like we just kind of throw a bunch of data at the AI and see what happens.
Yeah, you're pretty much right. Unsupervised learning is like we give it data, but there are no labels, you know? So the AI's job is to kind of like find hidden structures in that data or groupings completely on its own. So it's kind of like, you know, if you were exploring like a new landscape and you didn't have a map, you have to kind of figure out the lay of the land yourself.
Interesting. So it's not about like matching things up. It's more about discovery and finding those patterns on its own.
Exactly. Yeah. And this is super useful for like exploratory data analysis, things like that. Some common examples of what it can do are like clustering similar data points, you know, grouping them together, or even like reducing the complexity of data, so simplifying things, or finding like associations and connections between different data points.
Okay, so we've got supervised learning, we've got unsupervised learning, and then there's reinforcement learning. And I kind of picture this one like training like a digital pet or something, where like it gets rewards when it does something right.
Yeah, you're actually pretty close. So reinforcement learning is kind of inspired by behavioral psychology. So the idea is that we have an AI agent and it's interacting with an environment. And when it does something desirable, it gets a reward. And when it does something undesirable, it gets penalized, so it gets punished. And the goal of this whole thing is for the AI to kind of figure out, okay, how do I maximize my reward over time? You know, how do I get as many points or whatever it might be as possible?
So it's like learning by trial and error, figuring out how to get the most rewards, the most points.
Exactly. Yeah. And this is how AI has actually learned to play like really complex games, like Go, for example. I don't know if you've ever played Go, but it's a really complicated strategy game. And AI was able to beat like the world champion at Go, which was a huge milestone in AI.
That's super cool. So, okay, we also have semi-supervised and self-supervised learning. Are those just like fancier versions of the first two, or how are those different?
So semi-supervised learning is like a hybrid approach. You know how in supervised learning we give it lots of labeled data? Well, with semi-supervised learning, we actually only use a small amount of labeled data to kind of guide the AI, and then we give it a bunch of unlabeled data as well. So it uses that small amount of labeled data to kind of like get started, and then it figures out the rest from the unlabeled data. And then we've got self-supervised learning, which is kind of subset of unsupervised learning. And in this case, the AI actually generates its own labels from the data.
Oh, wow. So it's like creating its own learning signals from the information it has. That's wild.
Yeah, so it's being really resourceful. For example, a common example is like, you know, let's say it's trying to understand the structure of language. So it might be given a sentence with a missing word and has to predict what that word is. And by doing that, it's actually learning about the relationships between words and how sentences are structured.
So we're moving into AI being creative in a way.
Yeah, in a way, yeah.
Okay, so next up we have transfer learning, which sounds like it saves everyone a lot of time.
Yeah, it definitely can. So transfer learning is basically leveraging knowledge that's already been gained. So let's say an AI has been trained to recognize cats.
Okay.
Like thousands and thousands of images of cats. It's really good at recognizing cats now. Transfer learning basically says, okay, can we use that knowledge that's already been learned to now recognize something that's related, like maybe lions? Because lions are also felines, they have a lot of similarities to cats. So instead of starting from scratch, we use that pre-trained model and just kind of fine-tune it for the new task. So we don't need as much data for lions because it's already got a lot of the foundational knowledge.
So it's like building on what it already knows, which I'm sure saves a ton of time and resources.
Exactly, yeah. And it makes AI a lot more efficient.
Okay. And then finally, we've got deep learning, which seems to be like the big buzzword these days. Everyone's talking about deep learning. So what is it and why is it such a big deal?
So deep learning, it's actually like a really powerful subset of machine learning. And it uses something called deep neural networks, which basically means they have many layers.
Okay.
And these networks are really good at automatically learning features, but they do it from huge amounts of data. And this data can be like images, speech, text, all sorts of things. And the key thing is that they learn these features through like a hierarchical process. So it starts with simple features, and then it builds on those to learn more and more complex features as you go deeper into the network.
So it's like the depth of the network actually allows it to process more complex information.
Exactly, yeah. And that's why it's been so successful in things like image recognition, natural language processing, and all these areas where we're dealing with really complex data.
Okay, and then finally we have hybrid learning approaches. So is this basically just combining all of these things together?
Yeah, that's pretty much it. So hybrid learning approaches basically take the best of different learning methods and combine them together. So, you might have like a combination of supervised and unsupervised learning, or reinforcement learning and deep learning, all sorts of combinations. And the idea is that you can kind of leverage the strengths of each approach and overcome some of their weaknesses.
So it's like AI strategizing on how to learn best.
Exactly, yeah. And this is really useful for tackling those really tricky real-world problems that often require like a more sophisticated approach.
Well, I feel like we covered a lot of ground today. Thank you so much. That was a really interesting and thorough explanation of all the different ways that AI can learn. So for everyone listening, I think the big takeaway is that AI learning, it's not just one thing, it's a whole toolbox of different techniques. And each of these techniques is suited for different situations and different types of data. So understanding these core approaches, it gives you a really valuable framework for, I think, really appreciating all the advancements that we're seeing in AI, because there are so many advancements happening all the time and it can be hard to keep up.
Yeah, definitely.
So this kind of gives you that foundation to understand what's going on.
Yeah, and to kind of look ahead and see, okay, what might be possible in the future with these approaches.
Right, and I think on that note, just a final thought for everyone listening. Think about like a problem in your own life or maybe in your field of work, whatever you're interested in, and ask yourself, how could one or more of these AI learning approaches be used to tackle that problem? What kind of unique advantages could each method offer? So that's something to think about. And thank you for joining us for this deep dive. We'll see you next time.
Thanks for having me.